A very warm welcome to all of you. Myself Rajan Choudhary, Professor in the Department of Civil Engineering, Indian Institute of Technology, Guwahati, instructor for NPTEL MOOC course Pavement Construction and Technology, funded by Ministry of Education, Government of India. Our today's lecture will be under Module 12, where we will discuss about the design of recycled mixes. In this particular one, we will discuss about the design of hot recycled mixes. So, at the very beginning, I would like to acknowledge the use of text, information, graphs and images sourced from various textbooks, codal standards, journal articles, reports, newsletters and public domain searches. So, as we discussed in the previous lecture, under the recycling, specifically hot mix recycling, it is the process in which reclaimed asphalt pavement, or many a times it is known as reclaimed bituminous material, are combined. What is done in this particular recycling, hot mix recycling, is the reclaimed asphalt pavement material or the reclaimed bituminous material are combined with new called as virgin aggregates also and virgin binder, sometimes along with a recycling agent, to produce hot mix asphalt, or we can say the recycled hot mix asphalt. So, similar to conventional hot mix asphalt, recycled mixes must be properly designed, as the requirements are there for a conventional hot mix asphalt. The same requirements are there for our recycled mixes. Must be properly designed to ensure satisfactory performance. When designed correctly, recycled mixes can exhibit properties comparable to those of, and in certain cases they have been found to give properties even higher or better than your conventional hot mix asphalt. So, the design of recycled mixes aims to ensure that what specifically targets are that they meet the same requirements as expected of mixes prepared with the virgin materials. So, when you prepare a hot mix asphalt using virgin aggregates, virgin binder, and then there are certain requirements. So, the same requirements are expected to met out by the recycled mixes also. Their performance, if not better, should be at par with or superior to that of your virgin asphalt mixes. So, we have the guidelines IRC 120/2015 on recommended practice for recycling of bituminous pavements. In addition to that, many documents are available which gives information related to the recycling of hot mix asphalt. Specifically, like one is mentioned here, asphalt hot mix recycling, the Asphalt Institute Manual series number 20. Now, what are the key characteristics of reclaimed bituminous material or the reclaimed asphalt pavement materials is that is important to understand when we are doing this recycled design of recycled mixes. So, reclaimed in situ bituminous material used for recycling typically exhibit the following characteristics: the wrap which is obtained, or we can say the RBM which is obtained. What are the typical characteristics of that material? One is aged binder. This particular one is extracted from a surface which might have undergone an aging for a long period of time. So, the binder which will be present in the wrap will be an aged binder. So, the bitumen becomes aged, oxidized and hardened over time, resulting in a significantly higher viscosity. So, they may have much higher viscosity compared to the viscosity of virgin binder. Compared to fresh binder of the same grade used in the original construction. So, like when we pick up the VG30 binder, we target for a viscosity of 3000 poise, but under an aged condition after a service life of 10 to 15 years, the viscosity may be around 40,000 poise. So, there may be a significant amount of aging or hardening of the binder which may take place. So, the wrap which will be there will be having the aged binder. Then second is the crushed aggregates. So, during the reclamation process, especially in cold milling, aggregates may undergo crushing. In addition to this particular one, there will be some crushing of the aggregate which may take place during the service life of that mix also under the application of traffic loads. So, this may alter their grading from what is there in the original mix. So, you might have information about the original mix which was constructed some years back, and when you extract this wrap and you check the gradation, you may find significant difference between the gradation of the wrap and the gradation which was there in the original virgin mix. Material variability. Reclaimed bituminous material may have variability in terms of what variabilities may be there in terms of aggregate gradation properties. If it is a big stretch, the source of aggregate may have changed in that particular case, or the composition of the mix might have changed. So, then you can experience a change in the aggregate gradation also, change in the properties of the aggregates also. And if the stretches are far enough, or the wrap may be extracted from different layers. If it is extracted from the wearing course or extracted from your base and binder course, then the grade of the binder may also vary, and depending upon the source of the material also keeps on changing. During one particular stretch also, you might be getting for one length of construction aggregates from one source, and then after some time the aggregates may be coming up from different source. So, in that case the source variability will also come into picture. So, these material variability may be there with your wrap. Now, the usual 4 components which are involved in hot mix recycling is, first is the wrap, or which is your reclaimed asphalt pavement, reclaimed, and the other one is reclaimed bituminous material. These are the synonyms which are widely used. We have the virgin aggregates if you require to add some virgin aggregates, virgin asphalt binder which is also required, and some recycling agent may be incorporated. So, 4 key components or main components of a recycled mix or recycling are the wrap, the virgin aggregate, the virgin binder, and the recycling agent. The recycled mix design procedure consists of 2 main steps. What are those 2 main steps? One is the material evaluation, that is the evaluation of your specifically wrap along with the evaluation of your virgin aggregates and virgin binder, and the next step is your mix design. So, here we will not discuss about the evaluation of your virgin aggregates and binder, because that is as per the standard conventional design of virgin HMA mixes. Here we will more focus on the evaluation of the wrap. So, the material evaluation, the purpose of this step is to assess the properties of the component materials, which may include the wrap also and the virgin materials also, but here our main focus will be on wrap, and develop an optimum blend that satisfies the mix requirements. So, finally, the blend of aggregates and binder to give you the mix requirement. Second is, so this is what are the conventional steps in case of any hot mix asphalt. Second is mix design. Here it focus on determining the appropriate type and percentage, what specifically the bituminous binder. Based on the results on the compacted trial mixes, how we evaluate the mechanical properties and the volumetric properties of compacted mixes. On the base of that, we give the optimum content of our bitumen under the design of bituminous mixes. So, the main steps of the material evaluation and mix design process during design of recycled mixes specifically involves what? First is the collection of representative field samples of wrap. So, the wrap may be there lying at some crusher plant. So, there may be different stockpiles may be there. So, there one part is your collection is there, your stockpiling is there, and then sampling is there. So, that exercise has to be done with the wrap. Second is conduct laboratory tests to analyze the wrap composition. Specifically, the important things are the how much amount of binder is there, what is the consistency of binder, what is the aggregate gradation, and aggregate physical properties which may be required to ensure. Determine the required quantity and sizes of virgin aggregates to be added. Now, there will be a target gradation for any mix. So, a share of aggregate gradation will be there from wrap. Now, you need to proportion virgin aggregates in a manner that the combined is able to achieve the desired aggregate gradation. Select the appropriate type and grade of the virgin binder. Already aged binder is there on the portion of the wrap which is introduced in recycled mixes, and then there is virgin aggregates which needs the coating of the binder over it, and some binder may be because the existing wrap may be having insufficient aged binder. So, some more binder may be required for providing an extra film over it along with the film over the virgin aggregates. In addition to that particular one, many a times recycling agents are also used or softer binders are also used. Then after this particular one, in a similar fashion as we do for conventional hot mix asphalt, we will prepare compact and test these trial mixes at different binder contents and then finalize the optimum mix combination. So, which meets our design requirements. So, these are steps which are there in the case of design of recycled mixes. Now, coming to the collection, specifically stockpiling and the sampling from RAP, some important steps are important to be followed. First of all, avoid further crushing of milled RAP. Use as it is or screen to remove oversized particles, because in cold milling already a lot of fines are generated. So, it is always preferred that we can use the RAP as it is instead of going for further crushing, because then more fines will get generated and this will reduce the use of the RAP, because you have to meet out some target gradation. So, most of the time we prefer to use RAP as it is, but if definitely if you are targeting for a layer where some specified aggregate sizes are only mentioned and your RAP is maybe having higher sizes of aggregates particles, it needs to be crushed in that case. Keep stockpiles free of contaminants from start. This is important. There may be a distress layer from which the milling has been done and the RAP has been stockpiled. So, it should not be treated as a waste, because otherwise if it is thrown, if it is dumped or stockpiled in an improper manner, it gets contaminated by the dust, by the other waste, other aggregates, soil at the the site where it is stockpiled. So, the care has to be taken in this particular manner. This should be treated as an important aggregate material. Control moisture. Another, we have discussed during the different hot mix recycling operations that the amount of moisture which is there present in the RAP is a big contributing factor towards how much amount of RAP can be introduced. So, we always try to keep the moisture content in the RAP as low as possible. So, we will prefer that the stockpiles are covered and under shelters or in buildings, and we will prefer to have the conical shaped piles of this particular RAP is to be there, so that with the help of it water gets easily drained out on the sides. Limit stockpile height also, specifically we do not go for heights more than 3 meters, because otherwise self consolidation may happen and bigger chunks may be formed. Maintain consistency. We can maintain the consistency during stockpile also, because if we are knowing this material is coming from this particular project and this particular layer, then it can be stockpiled separately, and the other one from other project can be stockpiled separately. So, this will help us to reduce the variability which may be there in the RAP. So, well managed RAP stockpiles generally show uniform gradation, bitumen content and binder properties. So, then it is very helpful for us in the recycled mix design. Important common steps, especially now you have these stockpiled are there. So, you need to collect the samples for the material evaluation. Now, you can do the sampling at various locations and you have different requirement of frequencies also. So, it says it is recommended to ensure the quality of the RAP. For that particular one, you can at least go for one sample per 1000 tons of RAP, and at least 10 sets may be recommended to ensure the statistical reliability. So, that is another, that minimum 10 number of samples can be picked up so as to ensure from the statistical point of view. So, sample collection, and from where do you collect these samples? It can be collected directly from the pavements from where it is milled off. So, from there itself we can collect from the pavement surface itself through the coring or during the milling itself, scheduled for milling, or from the transport trucks when it is the milled, when it is put in those trucks and tippers. So, from those tippers directly the material can be collected, or once it has been stockpiled. So, from the stockpiles it can be collected. Now, important part is representative sampling. So, a stockpile is there, so you need to take out a good number of samples from different locations of the stockpile. So, it says usually obtain 5 to 10 representative samples from different locations within the stockpile, and it is always preferred to remove at least top 15 centimeter of the material from the surface to minimize segregation. So, these are some general considerations which should be given while you are collecting the samples from a stockpile to evaluate the RAP. Sample preparation sieve the collected material and any material retained on the 50 mm sieve is usually the larger sizes of RAPs, because that may be only few sizes, a small share may be present. So, in that case it is better to discard aggregate RAP sizes which are more than of 2 inches size. Now, once the sampling has been done, we need to go for the evaluation of the reclaimed asphalt pavement or the reclaimed bituminous material. And for this particular one, since we know that the binder which is present is already long term aged and there may be some changes in the gradation of the aggregate which is present. So, what we are trying to evaluate from this particular one, we are trying to evaluate the binder properties, and we are trying to evaluate the aggregate properties. Now, binder properties, it says with aging the binder loses lighter fractions resulting in increased viscosity of the binder in the RAP and reduced ductility. So, we want to just ensure what is the status of the viscosity of the binder which is there over the RAP. Aggregate properties, as I mentioned, gradation may change over time due to degradation by repeated traffic loads and by environmental exposure. So, what initial gradation have been there during the construction, there may be a significant change in the gradation which may happen. So, the RAP needs to be ensured for the binder properties also, aggregate properties. Hence, determining the composition of RAP at the outset is very important. Standard practice, what is usually done evaluating aggregate gradation, what we require is aggregate gradation. We most of the time require binder content and the viscosity of the aged binder at 60 degrees centigrade. So, because we use for our neat binder grading system also viscosity at 60 degrees centigrade. So, we prefer to determine the viscosity of aged binder also at 60 degrees centigrade. At least 5 representative RAP samples could be preferably tested and their mean values can be then used for further analysis. So, we can have different number of samples at least so as to work out the mean to have a better confidence over the results. Now, how to determine the amount of binder content and to have the binder for determination of its properties, specifically say viscosity. So, to determine bitumen content and recover aggregates for gradation and property analysis, two common approaches are used. One is the ignition method and second is the solvent extraction method. Now, we have the RAP with us. So, from there we want to extract the binder to determine its gradation and certain physical properties. We want to extract the binder also to determine how much content of binder is there along with what is the state of binder is there. So, two methods which are quite popular is ignition method and the second is the solvent extraction method. The first method is which is ignition method. We have ASTO specifications also, ASTM specifications also, is widely used techniques in which the RAP samples are subjected to controlled burning to higher temperatures in a furnace to completely remove the bitumen. And what you get, the recovered aggregates are then used for gradation analysis and any other property determination. So, this is one way. Here you recover the aggregates and which you can further test for their physical properties or for their gradation, but you do not have the binder available. You can get the binder content. So, you will get the binder content, the remaining weight of aggregates will give you the binder content. You will have the aggregates which you can sieve and get the gradation. You can determine some of the physical characteristics also of the aggregate. The second is solvent extraction. Here the binder is extracted from the RAP with the help of some solvents. So, solvent extraction using trichloroethylene or other solvents has been in practice from many years. It is also quite effective in determining bitumen content because you are able to extract the binder from the aggregates. So, you have a solvent which is having a binder and the aggregates which are getting separated out. So, again the aggregates which are separated out from the binder can be used for their gradation determination and for their physical properties, and then the solvent which has the binder in it, from there that binder can be extracted from the solvent and then can tested for its consistency or viscosity or other properties. So, now in this one we have a possibility for extraction of binder also for its evaluation, and we get the binder content. So, it further allows the recovery of bitumen from the solvent to determine its characteristics and viscosity. However, this specifically the solvent extraction method has challenges specifically because of the solvent which is used. Health and environmental concerns are there, and there may be certain aggregate types depending upon what type of solvent is there and what is the grade of binder and the state of binder which is present. The solvent may not be completely able to extract the binder from the aggregate. So, these may be certain concerns may be there in some peculiar type of recycled mixes. Now, once you have recovered the aggregate, you can measure its gradation and you can measure the physical properties of the aggregates. The other popular method is you can determine, as we know during the hot mix S4 design, we need to know about the effective specific gravity of the aggregates so that we can work out the theoretical maximum specific gravity. So, here what can be done? We can first work out the theoretical maximum specific gravity of a wrap mix. So, as per the conventional method, which is rise method which is there. So, for determination, like if I want to determine, it is an indirect method. If I want to determine say a bulk specific gravity of the reclaimed bituminous material, then first I will estimate or I will determine the theoretical maximum specific gravity using say a rise method. There are many other methods. This is one example. By rise method you can work out the theoretical maximum specific gravity, and then on the basis of the theoretical maximum specific gravity, you can work out the effective specific gravity of the aggregates, wrap aggregates. Now, here what is required in this particular one? You need to know the bitumen content in the wrap, that already you determined during the extraction process, whether it is ignition process or ignition method or the solvent extraction method. In both the cases, you will be able to have your binder content in the wrap. So, you have binder content in the wrap, you through your rise rise method you have the theoretical maximum specific gravity. So, in that case only one thing which you required is you have to estimate the specific gravity of the binder. So, that you can get from the existing records which are available when the mix was designed. So, if that information is available with you, or you can get the effective specific gravity of your rag aggregates, and then from the already existing records you can work out. So, the other important thing is you can know into the how much is the binder absorption was there. So, assumptions for bitumen absorption and binder specific gravity are required, and historical data for these values at each plant should be reviewed, and so they can be used, and you can ensure that how much change was there in these parameters specifically during the construction of these courses. So, these are some of the methods which can be used to estimate some of the characteristics. So, in that case we can estimate the bulk specific gravity of the wrap also, because now we have the effective specific gravity which is there with us. So, from the effective specific gravity and the percentage of bitumen absorbed in the aggregates which we got from the historical records, we can work out the bulk specific gravity of wrap also, because this bulk specific gravity of wrap is required, as we know, in the computations of volumetric computations during the mixed design, like VMA is there, where you require to work out the bulk specific gravity of the aggregates. So, accuracy of these values highly depends upon the reliability of the estimated bitumen absorption, because that you need to work out from. So, that is why even in earlier lectures we mentioned that the how do we maintain the record of the different steps which are involved during the mixed design is very important in later course, even for recycling also. Now, the other end, this is we have done the evaluation of the aggregates in terms of gradation and in terms of some of the physical properties, like to get the idea about the bulk specific gravity of the wrap aggregates. Second is the important aspect is to check the viscosity of the wrap binder or the consistency of the binder which is there in the wrap. So, for this one, as we mentioned, the solvent extraction method is to be used. Bitumen extraction is commonly performed, and how the bitumen is extracted from the solvent, it is mainly performed using the centrifuge extraction method. Here you can see this is a centrifuge extraction method, where in this particular one the binder is extracted because the solvent goes off, and then in this particular one and the binder is separated. But in the conventional centrifuge extraction method, there is that it may contain a bitumen and ultrafines passing through this specifically, because when the solvent is taken out from this combination of solvent and binder, some of the fines are also taken out. So in that case, again later must be removed by using a secondary high speed centrifuge. This is a high speed centrifuge where these fines are again recovered out of it, because otherwise it will always lead to higher binder content. So in the wrap, so this in addition to the standard centrifuge extractor, high speed centrifuge is required for removing the ultra fines from your solvent, which is they are used in this particular one. And then now you have this particular one where the binder is getting dissolved in the solvent. So now from that solvent you need to recover the binder. So what you did, you took the wrap, you were having the solvent, you put the solvent through it, and that solvent along with the binder was extracted first through the centrifuge, standard centrifuge. Now this solvent along with binder may have some fines also, small fines are there. So that again need to be separated out by this high speed centrifuge. So now you have solvent with binder itself. Now from that solvent having binder, you need to extract the binder. So for this particular one, various methods are used. One of the method is specified by ASTM D5404, which is using a rotary evaporator. So there in this one, you are able to recover the binder from the solvent, which can be further used for any measurement. It may be viscosity, ductility, softening point. The most important one is the viscosity at 60 degrees centigrade. And specifically why 60 degrees centigrade? Because we need to work out the grade and quantity of virgin, specifically the grade of the virgin binder which is to be added in the recycled mix is worked out on the basis of the viscosity of wrap binder at 60 degrees centigrade. Now the viscosity of the aged binder is needed to determine the quantity and grade of new binder. For recycled mix, we have these standard vacuum capillary viscometers through which we can work it out. Many a times recycling agents are also used. Key purposes of these recycling agents are to restore the properties of aged bituminous binder to a consistency suitable to the intended construction, because as I mentioned, their viscosities may be very high compared to the viscosity of virgin binders. To regenerate the recycled HMA mix, because they are already hardened binder is there, so we need to regenerate those binders to its optimum durability. So for that particular one, the recycling agents may be used, and even in some cases the wrap may be having, say, a lower binder content compared to what it is to be there in the new mix which we are trying to have. So there we need to put up the additional binder also, so that regenerating agent forms to add that particular additional binder requirement also. Finally, to give the required amount of binder which is required for the mix design parameters. Now once what grade you have determined the viscosity of the recovered binder at 60 degrees centigrade. So what should be and say a wrap percentage is used. So what should be the percent grade of the new binder to be used? So there are certain general principles which are widely used on the basis of experience. One says, if we are designing any recycled mixes where only 20% of wrap is getting incorporated, then generally we can keep the grade of the binder of neat binder same as we are doing for a virgin mix. So you don't need to go for a change in the grade. So if say in a particular region you are using VG30 binder, and for that if a mix is prepared with 20% wrap, you can go with VG30 grade itself, no need to change the grade. In other cases it says, if the range of the wrap is from 21 to 30%, then one can go for one softer grade compared to the. So, if as I mentioned, if I am using VG30 and I am going for use of wrap in the range of 21 to say 30%, then in that case for the virgin binder, new binder, I can go for a softer grade like say VG20 is there as per our codal requirements. So, this what grade is to be used is already our IRC 111 says that in what regions you can go with which grade. So, once that needs to be decided, and then on the basis of how much amount of wrap is incorporated, if less than 20%, no requirement of change in the grade of virgin binder. Most of the time this is with the generally this is what is adopted in most of the design of recycled mixes. If it is good enough, you determine the grade. We will see in the next slide. We can measure the viscosity and we can determine also, but these are some of the thumb rules we can say. So, if 21 to 30%, then you work out with one softer grade. So, if one region I am using VG40 and I am using say 25% of wrap, so for the new binder I can prefer to go for a VG30 binder. Now, determination of if this is not working, we can determine also the grade of virgin binder. This is for that particular one, we have blending charts which is there. This is one right on, this is a blending chart which has been showed, and what is required to make use of this blending chart. You can see there is a log viscosity which is presented on the y axis, and this is the percentage of new asphalt binder with respect to the total binder. So, how much, if it says 40, that means 40% in the total binder, 40% is new. It says 80, it means 80% is new binder and 20% is what is we are getting from the wrap. So, here to make use of this blending chart, what one requires is the target viscosity, which is specifically to the grade specified for the project which is selected. So, in one region, if I am looking for VG40, then my target viscosity may be 4000 poise, because that is the, for this particular grade, this is my target viscosity. So, I for that combined virgin as well as the aged binder, this should be my target viscosity. So, the blending chart relates the viscosity of the aged wrap binder with the proportion of the virgin binder in the recycled mix to determine the virgin binder grade. And so, this is what it is. It is preferred, but through this particular one also it is said that if you, I will give an example of it. Say for an example, it is a small, say simple explanation which has been created. Say if the viscosity of a binder in a wrap is say around 80,000 poise. So, this has been shown here, say around 80,000 poise. Sorry, this is the target one, this is the binder, the viscosity of the aged binder which is shown here, and my target, I want to have a mix in a particular region for which VG20 binder is to be used. So, my target viscosity will be 2000 poise, because I am preferring to use for a VG20 binder. Now, if the wrap content is the of this particular wrap mix is 25%. So, and having a binder content, when I did the solvent extraction method or ignition method, I found that the amount of binder which is present in the wrap is 3.8%. So, in the total recycled mix, 25% is coming from the wrap and remaining 75% is from the your virgin mix. Now, this 25% is giving me 3.8% binder. So, and my, if I know that the target demand of my binder may be say 5%, I am giving just an example to make use of this blending chart. So, the binder which will be obtained from the wrap will be 3.8%. Along with the how much share it is having, 25% in the recycled mix. So, 0.95% binder I will get from the wrap, and what will be my requirement, because I am looking for a target of 5% of binder content. So, remaining 4.05 is to be new binder. So, that shows that this is around 81%. So, here I can show this is my percentage of new binder with respect to the total binder 81, and this is my the viscosity of my aged binder, this is my target viscosity. So, what I will do, I will connect this particular one on the blending chart, the target viscosity with this percentage of new binder, and this point B is marked. So, this is how I get B. Then I join a line from this aged binder viscosity passing through this point, and it is extended here. What the viscosity I get from here is to be the viscosity of my virgin binder. So if I get, see for an example, if I am getting somewhere here around 800 poise, so in that case I can use Vg10, because Vg10 is 1000 plus minus 20 is there, in that case plus minus 200. So in that case you can use Vg10 binder. So this is how this blending chart is worked out to determine the grade of the virgin binder also. But in addition to this, it is always stated that it is preferred that the selected grade should not be more than 2 grades softer than the normally the specified. So it should not happen that if Vg40 is to be used in a region, you are going up to Vg10 only 2 grades softer. I have gone from Vg30 to Vg20, but not more than that. So even when you are using a blending chart, if you get a viscosity very low, but normally not a reduction, from the experience it says there should not be a reduction of more than 2 grades of the binder. Now we have the how much, if we are aware about the grade of the binder which is required, the amount of wrap we are using, the gradation which we are using, then we will proceed for the mix design in the standard manner. So here, and since we are currently following the Marshall method of mix design, so same IRC 111 2009 will be used, and the parameters defined by it has to be ensured for the recycled mixes also. So first the aggregates extracted from wrap is treated as one of the constituent, and they need to be blended with the virgin aggregates to achieve the whatever your design gradation is there. So this blending has to be performed from the wrap gradation and the gradation of your virgin aggregates to get your desired aggregate gradation. And then when you are preparing the laboratory specimens, some key considerations are required. One is, in laboratory mix, wrap is usually preheated in a pan not more than 1 hour. This is usual because you have the already aged binder over this particular one to the mixing temperatures, while virgin aggregate is heated to about 10 degrees higher than the mixing temperatures, and then they are mixed in this particular one. The wrap and virgin aggregates are first dry mixed, so that they, through the conduction, the wrap gets further warmed up, and followed by the addition of the required amount of virgin binder. So whatever deficient, as in the previous example we have seen that what we are having from the wrap, the remaining is to be the new percentage of the virgin binder, and the grade already decided from the blending chart. So now we have added the additional virgin binder to it, and then we need to compact it by our standard procedure. And so this is to be there, that in the first case the target was say 5%, then we can do at different binder contents, and we will prepare specimens at different binder contents, compacted specimens. These compacted specimens now need to be evaluated for volumetric properties and mechanical properties in the similar fashion as we did for the virgin mixes also. And from that particular one, we decide the optimum combination, specifically the binder content for those percentages of wrap. So this is the important aspect, specifically in recycled mixes, is the evaluation of the wrap in terms of its gradation and in terms of its properties, which may be required during volumetric measurements. Second is the binder content determination, the right amount of binder content determination, which we get from the ignition method also, or from solvent extraction method. And if you want to, if lower percentages of wrap are used, then as mentioned, less than 20% of wrap is used, then directly you can go for same grade. If more in the range of 20 to 30, you can go for one softer grades, or you can use the blending charts. And then from the blending charts you get your virgin binder grade. So you prepare specimens of recycled mixes at different binder contents, evaluate it for volumetric and Marshall parameters as we did for the conventional mixes, to finally get the optimum binder content for recycled mixes also. So this is all about the design of recycled mixes. Thank you so much.